Okay, great. Thanks everybody for coming. Today we're going to be presenting on SQL Server, Exploitation, Escalation, and Pilfering. So if you didn't come to see that talk, you're probably in the wrong room. But before we get started on that, let me just, I guess he did a pretty good introduction there. I think he covered everything, yeah. So we're pen testers. I guess the main point I want to make, Auntie and I work for a company called NetSpy right out of Minneapolis. Most of what we do is network penetration testing, application penetration testing. So as we walk through these slides and the processes and the attacks, keep in mind that we're really coming from the attacker's perspective. So some of these techniques are just pen tester techniques, or more commonly used by pen testers, but these can also be used by internal employees, external attackers, and we'll really try to show how the database itself, the database server that supports all the data for your applications, can be attacked from multiple vectors. So at a high level, here are the points we're going to cover today, or at least attempt to. We're going to cover database entry points. So how do we get into that database so we can start doing bad things? How do we escalate between different positions on the server, on the network, between databases? So what 2 through 5 kind of cover those. We're going to try to illustrate how easy it is to really scrape SQL databases very quickly for sensitive data. This is really good for pen testing, for evidence gathering. But it's also nice for DLP and PCI to see if you have sensitive data out there on your non-PCI networks or non-protected networks that shouldn't be there. We're also going to walk through 2 kind of cool escalation methods, basically leveraging database service accounts to kind of traverse the network and traverse databases. And then my personal favorite, database link crawling, which is kind of the cherry on top of the presentation, hopefully. So why target SQL servers? As I mentioned before, databases are really what run everything in the back end. That's where all the critical data is, it's where proprietary information is, and when attackers are looking for info, the goal of getting on a server is just a kind of a means to an end to eventually get to a database where they can pull down all your social security numbers, all your credit card numbers, your client data, proprietary formulas, your Coke formula, whatever your company happens to do. So that's why we targeted SQL servers specifically. The technology is pretty widely used in every big environment in the world, pretty much. It also integrates very closely with Windows domain authentication, local Windows authentication, which gives us a lot of flexibility as an attacker. Since it's so integrated, it allows us to kind of go into the database, back out to the operating system, or from the operating system back into the database. So you'll see some of those tricks as we move forward. We'll also be releasing, or we have released, 6 Metasploit modules to support most of these attacks, so you guys can go back, understand these attacks, use them more in kind of an audit capacity, so you can fix some of the issues related to the problems we're going to be talking about. We chose Metasploit because it's really easy to use, and we really suck at programming. So there's a lot of pre-existing APIs that save us a lot of time for the authentication components and a lot of other things. It's really easy to manage out on GitHub. I don't know how many of you guys are developers out here. We've got a lot of developers. Can I see show of hands? At least 1 or 2 or 3. Okay, great. Development conference. I guess that makes some sense. And so we really like GitHub for version management, but also it's very easy to distribute the code. The idea is with all of these in the Metasploit base, all you have to do is update your Metasploit install, and you have our plugins, which is good. So for those of you who might be kind of ignorant of Metasploit, it's basically a framework for attacking systems, for escalating on systems, and for gathering data, essentially. It's an exploitation framework. So let's get started. So first of all, we're going to be talking a bit about entry points. So this is how we get into the database. We've kind of broken these into 2 major categories that we see a lot on pen tests. So first of all is the unauthenticated options that we see the most. SQL injections are pretty rampant still. We see them very, very often. And they're a good way to get into the database layer. Also, weak passwords. Sometimes databases are exposed to the internet. If you have database listeners exposed to the internet, you should seriously consider talking to your firewall team, because that's a big no-no. But on the internal side, this is a huge deal, even still. I'd say it used to be 9 out of 10 environments we come into, we would find databases with weak or default passwords. Now it's probably 7 out of 10. So it's gotten incrementally better. We're making progress, guys. We're making progress. So those are those. Authenticated options. So these are the attacker who happens to be a user, or a pen tester who has credentials potentially, or attacker who's acquired credentials. Usually you can come from database to a database. So these are database links, which we'll be digging into later. unencrypted connection strings, which a lot of users have access to. So these are on file shares. These are on scripts that are distributed to everyone on the network. Of course, sometimes these credentials are actually going across the wire in clear text as well, or the air. So always encrypt your connection strings no matter where they are. Do it well, do it right. We leverage that all the time. ODBC connections are another one. A lot of thick applications leverage this. So it's, for those of you who don't know what an ODBC connection is, basically it's a pre-configured database connection that's set up on your system. And very often it's used and leveraged by people who are doing like analysis in Excel. So it allows Excel to tap into the back-end databases so you can run numbers and do all kinds of fun stuff. So as an attacker, if I get on a system where there's already a database connection, I can just start sending arbitrary queries to that database server and start to escalate. So watching out for that is good as well. And then finally, client tool sets. So just people who should have access or shouldn't have access, just simply using client tools to interface with the backend database. And so the little image that I have here, I attempt to illustrate that a little bit. But all these slides will be up on SlideShare after. And if you guys have questions or something, we can address them at that time. So the first real scenario we're going to talk about is going from a database user, from a domain user into a database user. So I'm a domain user on the network. I really shouldn't have access to any databases because I work in HR or I'm doing something that doesn't require it. The issue that we see a lot during penetration tests, so this is real world, is that the domain users group, so this global AD group, gets added with at least logon privileges on a lot of SQL servers, just because it's easy. So when you're setting up an application, you're starting to do debugging, the DBA will simply just throw on domain users, so it just works, and then they forget to remove it. So that's kind of scenario one that we see a lot, that allows domain users to get database access. The second is a privilege inheritance issue, or feature of Microsoft authentication. So specifically with SQL Server Express versions prior to 2012, if you install that on a domain system, so I have my system, I'm connected to the domain, I install SQL Server Express, and then I decide I want to allow my development buddies or whatever to connect to me so we can run some scenarios. The second I open up that lister, your development buddies aren't the only people who have access. By default, through a series of privilege inheritance, every domain user on the network now has the rights to log into your database server. So that's kind of scary, and people don't realize that because it's not explicit in the privileges assigned within the database. If everyone has questions, I have another blog on that we can talk about later. So what does that evil user have to do, really? They just have to find the servers, they verify that they have access, and then they attack. So for finding database servers on the network relatively quickly, we really like this tool. It's old, but really works. Is SQL Ping 3. It uses like 4 or 5 different methods for enumerating databases on your network segments. Of course, it's kind of limited to your broadcast domain, so you can give it an IP range and say go. So that's great. You can also use it for checking for weak passwords, so it's good for auditing. Just be careful because in a lot of scenarios, what will happen is your database server, SQL server, will be configured to inherit your password policies from your domain. So if you have a lockout policy of 3 tries, you might start locking out like SA accounts or service accounts that actually do things, and that can cause some big problems. The second method that we really like is OSQL. And so for those of you who aren't familiar, OSQL is a command line tool. It comes native with every SQL version since like 2000. And it supports a lot of really fun options, one of which is this -L option. So if you just install SQL Express, type OSQL -L on your network, what it's going to do is send a broadcast message across your network. And it's going to say, hey, every server out there, are any of you database servers? And being the polite database servers they are, they respond in turn and say, yes, I'm a database server. And so now we have a list of targets. So we basically turn the database client into a database scanner in like one step. So that's kind of fun. Once again, a feature. It's a feature. It's an intended feature. So now that we have this list of database servers, we can put them all in this text file, SQL servers, and we can run this very simple batch script, basically, off the command line. So we're going to use the OSQL tool, and we're going to basically go through every server and attempt to connect to it. And the way we're going to do that is using this -E switch that's kind of bolded in red. What that allows us to do is use something called a trusted connection. That means it's going to use our current authenticated contacts to try and connect to the backend database. That means I don't have to put a password in. And we're going to see other scenarios where this is really interesting. So as a normal domain user, I run this, and basically the way this is written, it will say, I have access to this server, this server, this server, and then kind of error out on the other ones. So that's option one. Next, Sometimes we'll have other people's credentials, and we want to test what they have access to, especially during pen tests. This is very common. So SQL actually, Metasploit actually has a module called MSSQL. I did not write, or we did not write. It's been around for a long time, and it allows you to do 3 types of authentication, which is kind of native now in Metasploit. Standard SQL login, local Windows login, and domain login. So I can actually specify alternative credentials, which is something I cannot do with the native tool sets that come with SQL Server. So that is really nice. So if you wanted to do that, this is what the screen would look like. We're basically going to configure it up to connect with my basic user. I'm going to attempt to list the version, essentially, and this is what it would look like if you ran this in real time, more or less. So that's the first one. So now we basically have a foothold in the database. I'm now logged in, and I can issue queries to the server. So now I want to either get DBA access, or sysadmin access, as it's called in SQL Server, or I want to get operating system access so I can go around my ass to get to my elbow. So to do that in this scenario, we're going to go from database user to OS user, or OS admin specifically, using a very old technique called SMB relay. And the way we're able to do this, basically what SMB relay is in summary, it allows you to, if you're in the middle of a connection between server A and server B, if you have server A, you can basically intercept the connection, the authentication, and forward it off to another server, creating a legitimate authenticated connection to that server if it's accepted on the other endpoint. And then issue commands, which I'll run through that scenario shortly, so it'll become a little bit more evident what I'm talking about. The important thing to note here is that SQL Server supports a number of functions which can use UNC paths. So basically what I mean is the SQL Server has the capability to interact with the file system. And that can be the local file system, or that can be a share or a mounted file system. And so what normally happens in the process is if an application or a user decides they want to access the file system, they want to list the files, check if a file exists, import something from a file into the database. What the database server is going to do, if it's doing that against a remote share, is it's going to say, hey, file share server, I want to log in. And the file share server will say, sure, here's a nonce, just take that nonce and your password, hash them, and send it back. And then they're authenticated, and it can execute correctly. Oops. All right. So the 3 main functions that support this that we use in the modules anyways are XP directory, file exists, and get file details. Get file details doesn't work on newer versions, which is why it's not bolded and asterisked. Also, when you're running this, the database server is going to authenticate, right? Well, what's it going to authenticate with? It's going to authenticate with the SQL Server service. And so that service can be configured with a number of different accounts. It could be local system, it can be network service, local admin, domain user, domain admin, and depending on the user it's configured with really affects the outcome of trying to capture credentials or trying to relay credentials. So here's a basic capture attack. I'm going to go through this quick. I might actually just skip to the demo of the relay after this in the interest of saving time. But basically, Captain Evil's on your network, and he wants to do no good. So he connects to the database with his public privileges. He issues this XP directory to his evil system with file. He's basically now forced the database service account to authenticate him, or attempt to. Captain Evil basically gets the request and says, all right, here's a nonce I want you to use. But the attacker controls the nonce, or the seed. And so that will go off the database server. The database server will hash it with the seed, send it back to Captain Evil. And now the attacker can then just crack the password, or they can try to relay that off. I do have slides on how to do that, but we're running a little behind. So please go check out how the cracking process online. They are on SlideShare. I'll leave the deck open at the end so you can see it. Here's a brief overview of the actual relay approach. So in summary, Captain Evil would connect to the database, force it to authenticate to himself, forward the authentication off to server B, which has a service account configured with the same password. Very typical in enterprise environments. You'll have a service account for SQL Server that runs 50 databases. And the scary part is that 25 of those databases are PCI servers. The other 25 are for the blog, which no one vetted for security holes. So someone can come through the blog, do SQL injection, initiate this type of attack, and get access to the PCI servers because of a shared account.
What privileges do you need to run those store procedures? Do you have to be sysadmin?
Public by default. So, yeah. That's why it's so scary. It's something that's well known too. I mean, for the last 5 years, people have commented on it in the blogosphere and stuff. So it's not an original thought. We just made a module for it basically, and we're trying to create awareness. All right. So let's take a look at how this looks when we actually run it. So in this scenario, we did videos because the demo guys don't like us traditionally. So here what we're seeing is LVA, which is a database server. This database server is configured with the DB service account. And there's the IP, it's 161. It also has a web server on it, and that web server links to LVA's database. And we see this web application running, and it looks like that web application is susceptible to SQL injection. But you can firewall the 2R manually. Then we have database server, or DB1, which is a second database server, which is configured with the same service account. So we're going to configure our SMB relay module to basically forward the traffic off to the second database server. Then we're going to configure the SQL NTLM stealer module we created to first set the R host. So this is going to be the web server's host, or IP, excuse me. That connects to database 1, or the first database. Then we're going to set an injection point. So this isn't going to enumerate SQL injection for you. You have to know where the injection point is for this to work. But you can use other tool sets or manual processes to do that. So that's indicated by the bracket, SQLi bracket. And this is actually part of an API that's actually built into Metasploit. So they make it very easy to code. Here I'm listing out the current attacker's IP. So I'm going to be playing the role of the attacker or the SME proxy. It's sitting in the middle. That's Captain Evil. Making sure we're working off port 80. Show some options so you know it looks good. And away we go. So now at this point, it's executing that dirt tree against the first database server through SQL injection. And it's relayed the authentication off to the second database server. And it got 2 interpreter shells. Or 1 interpreter shell, sorry. I forgot to clear my cache there. And what you'll see is I had no access to either of the servers, and now I have basically system access on the second database server. So I know that can be a little convoluted, and I went through it a little fast, so please feel free to ask questions afterwards. Are we running? Okay. Oh, you want me? Okay. Sorry about that. We're having discussion. Okay. Sure you don't want to do this one? Okay, I'll just keep going. Sorry about the interruption. All right, so the next item we're going to talk about then is now we're an OS admin, and we want to get to be a database admin, because that means we get access to all the data, which is really what we want. So SQL Server is interesting. In its early years, they did not provide, or they automatically provided local server admins with DBA access. So even though I shouldn't have access to the data because of my job role, I can get access to it pretty much by default. Well, around the time they released SQL Server 2005, they made the decision, really these should be separate roles. Only the database admin should have access to the database. Server admin should only maintain the server stuff. And so they broke it apart so that by default, the local admin does not have access to the database that's being hosted on the server. What we found is that it's very trivial to bypass this control. So if I'm a server admin on a server running SQL Server to SQL Server 2008, if I can drop down into a system shell, I now automatically have the rights to take actions in an SQL Server as a sysadmin, because local system, for patch management reasons actually, was added as a sysadmin by default, kind of out of the box. So the problem with trying to fix this is that if you remove local system from the sysadmin fixed server role on the SQL Server, that means you probably won't be able to patch your SQL Server. So you either have this escalation path or you have missing patches. So there's no real perfect solution for fixing it, which is a bit of a bummer. And from attacker's perspective, I guess it's a good thing, but it's just kind of a reality of the implementation. And SQL Server 2012, they put a little more thought into it. And by default, the local system account no longer has sysadmin privileges or that DBA privilege. But we were able to work around that by simply migrating into the SQL Server process, which always has access to do everything because it essentially is the database. So there's a couple workarounds. What does this really mean? So for those of you who are relying on transparent encryption for security, you're out of luck. basically, transparent encryption means a user signs in and data is automatically decrypted on the fly, so they don't necessarily have to use the application. So you can do encryption at the application layer where it encrypts data before it puts it in the database, and then the application decrypts it when it comes out of the database. Transparent encryption basically means you create a database account, and when that account logs in, the data encrypts on the database layer instead of the application layer. And PCI, for example, deems this as acceptable because if someone steals your hard drive, steals your system, and takes it off into their whatever evil workshop or something, that in theory it's encrypted and they can't get into the database. The reality is that if that database server doesn't have an encrypted hard drive, that they can just bypass the local controls to get local admin, and then they can drop from local admin to local system, and then they can get into the database. So transparent encryption really isn't effective using this attack approach. And I have never seen a DBA or server admin encrypt their database server before because it really affects performance, and performance is kind of key in database land. All right, so how do we take advantage of this? First of all, we can use psexec if we want to just do it manually. Very common tool set. You can use the -s switch to run a command shell. And once you have that command shell, you can simply run os SQL -e. And now you're running as system with the privileges of system. You're using that -e switch to inherit the privilege, so you don't actually have to add a password. And then you can simply run a command. And in this instance, this example will return a 1 if you're a sysadmin and a 0 if you're not. And if you run this scenario, you'll get a 1 back. So, if you like GUIs instead, you can use psexec -i-s SSMS, which is my favorite management studio tool from Microsoft. They did actually a really good job on it. I enjoy working in it, so that you can actually run the management studio as system. But as an attacker, you might be kind of using Metasploit to get onto different systems, and so you'll often use psexec to get on a database server initially. So psexec is kind of like the original tool we just saw, but it's baked into Metasploit, so you can provide it like a hash, so you don't need the password, or you can provide the password, and it's basically going to create an interactive shell with a lot of different options that you can kind of call on. So the module we created for this is MSQL local auth bypass, aptly named, I guess. The way you're going to configure it is you're going to get your psexec session, you're going to background it, you're going to target your session, because you can have multiple interpreter sessions at one time. You want to make sure you're pointing at the right one. Then you're going to add a database username and password. This is not for authentication. This is the sysadmin that you're going to add to the database server. And so this is kind of what the screenshot looks like, and if you were to run it. Basically, it's going to go through here, check if you're already system. If you are system, we'll attempt to basically find the first database instance. If you happen to have like 5 database instances running on your server, I did add an option so you can target individual instances, which is kind of nice. And then we'll add that, and then once you have that, you can do your whale dance or whatever. Now you can just log in interactively. And I also added a flag in the module because you can't remove once you're logged in interactively, you can't remove your user while you're logged in. So I added a flag to the module, so you just type remove, set it to true, press go, and it will remove your account when you're done doing your evil deeds. All right, so this is kind of a blast from the past. I'm pretty sure everybody in the pen test community, security community, is familiar with XP Command Shell. Basically, it allows you to do OS-level command execution through the database. Everybody knows this. What we just wanted to reinforce briefly is that a lot of people are under the impression that XP Command Shell itself is the problem. So if I disable it, that's a fix. If I completely remove it, if I uninstall it, that's a fix. And the reality is that's not true. You can, unless you remove the full DLL, you can always reinstall it from the DLL, re-enable it, and start issuing local commands, to do whatever you need to do. So those are just things to keep in mind if you're trying to go from the database level down to the OS level. So next up, we have finding data, as I mentioned before. Commonly, we're going to want to target credit cards, social security numbers, medical records, etc. Originally, we came up with this super basic TSQL script. So this is native TSQL. You can copy and paste this right into your query window, press go, and it's going to go through and return data based on these keywords. So it's basically going to do a search of every database for columns that match these keywords here in red, and then return rows for all of that data. But there were some limitations to this. For example, this particular stored procedure doesn't exist on every version of SQL Server. That was a limitation. We wanted to have the ability to limit row count and execute it across multiple servers at one time. And so we wrote this module. And the cool thing about this module is, like I said, you can scan multiple servers at once. You can create a script and burn through every database server, SQL server in your environment. You can authenticate using different types of authentication mechanisms. A lot of people nowadays create a database group that lives in AD or Active Directory. So you can just add yourself to that group and then scan away. We added the ability to sample data because I don't want 4 gigs of data coming at me. It's just not useful. It'll probably crash my system or at least the module. So we allow you to throttle how much data you're getting back. And then we also count the number of rows because a common question from clients is, oh, that's great. You got 5 records with social security numbers or you have 5 credit card numbers. How many are in the database? What's the total impact to me if there was a breach? So that helps you answer those questions. And then also there's nice screen output and a CSV log file. So you can literally use this for, kind of basic auditing. I mean, it's not regular expression based, but it's all right. So let's take a look at this. We have a quick demo for this as well. All right. So here we go. We're selecting the module in MSF console. We're then going to specify the keywords. They're pipe separated, basically. You can do as many as you want. Sample size set to 1 by default. Excuse me. All right, I just kind of pasted it in for the sake of saving time. And away we go. Boom. We get a quick sample of a bunch of different databases on the same server, and we get a row count, so how many rows are affected. And I decide, oh, my client or my boss wants to see a larger sample size. I increment by 1, and now I have 2 row sample size, and you can keep going with that. The other good thing is by default, it's going to output the CSV log file. And that is going to look something like this. So here you can see we have everything from start to finish that you're going to need to do remediation, to go to the business unit or go to the development team and say we need to protect this data better. Okay. All right. Yep, crazy cat dance. All right. The last one I'm going to share with you guys before I give it to Auntie, who's way smarter and talented than I am, is service accounts. So we've talked about these a little bit, but you can do even more than we've already talked about. So we've done the relay between server A and server B, which is really cool. But if they happen to have something like SMB signing enabled on the network layer, it's probably not going to be successful. Or if you capture the credentials and they're not enabling LM hashes, it's going to take longer to crack the NTLM hashes, well, depending on the crack setup you have. So what we're going to do here is use XP command shell plus the shared, which is going to allow us to execute commands on the operating system under the context of the service account. And then we're going to use that OSQL minus E to basically execute queries as the service account. And so once again, if you have 2 servers running the same service account, they automatically trust each other. So I can query server A from server B and server B from server A. And most of that's never logged. And so that kind of looks like this. A real attack scenario. We've definitely done this during pen tests. Captain Evil comes through the cloud. He hits your firewall. He's led into the app. The app has an SQL injection, which gets you into the database. So now arbitrary query time. Start executing XP command shell with OSQL minus E. And now I can actually get onto DB2. And once again, in this scenario, let's pretend app server that's out here in the DMZ and DB1 are related to your company's log, which you don't really care about. But DB2 has all your PCI data. So now your PCI data was just compromised because you weren't segmenting those or isolating those service accounts. So things to think about. Hopefully that makes sense. Here's a little script if you guys want to try this at home. You might want to change super secret data to ADAT version if you're just doing a proof of concept for your boss and don't want to get fired or confuse him or her. And so that brings us to database link crawling. This is probably the coolest thing that we have come up with over the course of time.
Sure. So next we'll talk about database link crawling, like Scott said. What database links are, you can create database links from MS SQL Server to another MS SQL Server, or other data sources as well. But we're focusing on MS SQL servers. So you set up a link, and that allows you to run queries from database A to database B. So if you want to select data from another database, you can do it with the links. When you set them up, you set permissions for them. and any user who has access to the database server can follow those links. So it's public access for everyone. What we see often that the database links are configured with excessive privileges. Even if you have just user level access to a database server, those links might allow you to escalate your access, get sysadmin permissions on the next hop. The other cool thing about database links is that you can create links from server A to server B to server C to server D back to A. So those links chains can get pretty long, and the longer the chain is, the higher likelihood there is that you get some sysadmin access at some point. How you use those links, you use OpenQuery. That's just T-SQL syntax. So you select something from OpenQuery, database server name, and so on. Other cool thing about links is that there's a way to use XP command shell over those database links. So even if you don't have first sysadmin access, if you follow the links long enough, you might find a server where you can actually execute commands. Often we get tons of access. We don't really need any credentials except for the first server. Or if we do it through SQL injection, we don't need credentials at all. How these links work, you can see a diagram here where those links are just set up from DB1 to DB2, DB2 to DB3. These are user access links, so they are configured correctly so that the links don't escalate privileges. DB3 links back to DB1, but DB3 might also link to DB4, which might be an isolated segment or secure network where you want to control access that other people, or it would be harder to get there. We've seen this many times in production environments where we can follow the links and kind of bypass the access controls for the secure network. Some basic concepts for links. How do you list them? Stored procedure, SB linked server, linked servers. That just gives some information about the links. Or you can just select them from master sys servers table, and it has all the links for one database server. So how do you use the OpenQuery? So if you get access to database 1 or the initial database, you can select data from the linked server by using the OpenQuery. So you can do select server name from OpenQuery DB1 and then select server names from there. So what this query actually returns is not the linked servers on the first server, but on the linked server. And the same way, you can list linked servers on the linked servers, linked server. So you can just build longer queries when it follows the link path. It gets kind of ugly if you create really long queries because you have to duplicate all the single quotes. So you can have like 32 single quotes on each side of every field. But you get the point here. You can follow these links through the whole network. So if there are 50 servers linked, you can go from the first one to the last one for as long as the links work. I mentioned earlier you could run OS commands through the links using XP command shell if you have sysadmin privileges. There's just a little trick, nothing too fancy. You have to return some data from the link before you can execute arbitrary queries. So if you look at this example, we're running the SQL on HVA database server, but we have to return something from there, so we return just one. We're not doing anything with that data, but it supports batch queries, so you can, after the first select, you can add anything you want after it. So this will execute XP command shell and ping us back. We won't see the results when we run the query, but it will still execute it. So for this, to make this easy, we created two Metasploit modules. One with direct SQL connection, so if you have credentials to access the database, and another one with SQL injection. So if you find a SQL injection in an application, you can run the Metasploit module, and it supports error-based, union-based, or time-based injections, and it can do the same thing. So it will crawl through all the links that it can find, check the permissions on all those links, and if there is a server with sysadmin privileges or link with sysadmin privileges, it will then try to deploy a payload. These are available for download. They are not in the Metasploit trunk yet. They are on Scott's GitHub if someone wants them. We're going to submit them here shortly, but depending on how many fixes we have to make, they should be in Metasploit soon. I kind of went through these, the features of the link crawler. So it crawls all the links. It does output for the links, so gives a server name, all the links on the server, all the links on the linked server, and so on. Permissions for those. It puts all the data to a CSV file. So if you want to use it just to audit, it's pretty handy. The CSV, it just shows you all the links, and you can find all the links with excessive privileges. It works with 32 and 64-bit windows. The payload deployment, you can choose any payload you want. You can tell the module just to deploy a payload on certain servers. So if you have a link tree that has hundreds of databases, you can just say deploy on these 4 and just test all the other ones. And it does all the payload deployment through PowerShell memory injection. So it just has to put a really small file on the server. It executes it and pulls the payload from your reverse handler. So that should make it pretty hard for AV to catch it. How do you use this? If you want to get multiple shells back when you run it, you just start multi-handler in Metasploit, set the payload, say exit on session false, so it can accept as many connections as you want, start it in the background. You set up the module. Just a few important things about it is the get path. Like I said, it's not the SQL injection tool, so you have to know how to do the actual injection. You mark it with SQLi, set the type of injection, blind, error, union, set the payload, disable the payload handler, and if you find any links with excessive permissions, it will start giving you back shells. So here is kind of a normal network diagram of what we've seen. When we do an external test, we might find an application server with SQL injection that you can see in the DMC that connects back to database server in the internal network, DB1. Very often it's a public access, so we can't actually compromise the database server directly. But we can start following the links from there. So go from DB1 to DB2, DB3, and then I guess in the best case, we can find a link to the secure network, and that's with the excessive permissions, and that allows us to compromise the most important database. We'll show a little demo of this. So what we do here, we just start multi-handler, like I said. So it's listening, waiting for connections. We load the module, set all the options for the module. So we set the get path, where the SQL injection is, set the type to blind. And first we set deploy to false. So now it's just crawling the links, but it's not actually deploying a payload. And as you can see, now it's doing a blind injection, so it's a little bit slow, but now it's going through. It started from the LBA database. It had user-level access there. So we couldn't escalate there, but from there it goes to HVA, which is another server, and that's with user-level access as well. And currently, it's checking all the links on the HVA server. through blind injection. Takes a little while. And it finds HVA named 2K5 server, and that's with sysadmin privileges. So we followed a couple of hops, and we found a link that server that we can actually compromise. And in the last example, you can see that the link goes from LVA to HVA to name 2K5 back to LVA. And even though we didn't have sysadmin privileges on LVA in the beginning, the last link is configured with SA account, and now we can compromise the first server as well. So now we're doing the same thing with error-based injection. So just the injection URL is a little bit different. We set deploy to true. So now it's trying to actually deploy a reverse metapredator shell on all the servers where it has all the access that it needs. And this time it runs quite a bit faster. You can see we get the first shell up to 2 hops through the links. And then in the end, we get the shell on the very first server as well. CSV file where you can see all the links and the permissions on all those links. Sessions, you can see we have 2 sessions. And if we look at the first session, we can see that we are on HVA. That would not be normally accessible from the internet. More dancing. There are a couple of constraints for this module. It can't crawl through SQL Server 2000. It can get to SQL Server 2000, but the open query doesn't work on 2000 when you try to go through it. It can't enable XP command shell through links. So even if you have sysadmin permissions on a link, it can't enable it because the open query statement is a user transaction, and you can't change the server state through a user transaction. In the direct module, it tries to do it through RPC out calls, but it's not the default setting to allow those, so it most likely doesn't work. It only works on systems that have PowerShell, so 2K3, 2K, 2K12 have PowerShell by default. We tried to get it to work with all the systems using debug. That's in Metasploit, but for some reason the open query messes it up. We'll try to fix it soon, though. It leaves a PowerShell process running on the system after you've done. It doesn't leave a payload or anything, but the process is there. So if you run it many times, you get lots of PowerShells. And it doesn't allow arbitrary query execution on any of the crawled links. So if you don't get sysadmin permissions anywhere, there's no way to actually run, just collect data through those links. A couple of conclusions quickly. Configure all accounts with least privilege. System accounts, service accounts, database accounts, application accounts, and the links as well. Because most likely, if you have excessive privileges, there's some way to bypass all the controls. Validate input, web apps, stick apps, mobile apps, web services. Configure SMB signing. That's a good mitigating control for SMB relay. So that's not possible then if you have SMB signing enabled. Don't do drugs. Thank you.